This is G4c, and we're talking about apply properties of triangles and quadrilaterals in the coordinate plane. So basically this topic is a way of getting out of you your understanding of triangles and four-sided polygons while working on a coordinate plane. And so that's why I have the coordinate plane here. So you're going to end up doing a lot of problems like a couple examples I'm going to show you here. Alright, so here's the first example. I've got a coordinate grid. I've got 3 points on this grid. And this is point A, this is point B, and this is point D. And you're wondering, well, where's C? Well, let's see. If I connect these points, here. Now, this topic is all about getting at your understanding of specific polygons. In this case, it's a parallelogram. So what are all the properties that you know about a parallelogram? Well, the opposite sides are parallel. So what you're going to do is think like, okay, well, how do I know on a coordinate grid what parallel is? And hopefully you're thinking, it has to do with slope. And the slope of the sides has to be the same. And so what we're going to do is we're going to focus on this side right here between A and D. And here's what we're going to do. We're going to go ahead and remember, slope is rise over run. So we're going to go 1, 2, 3, 4 up, and 1, 2, 3 to the right. I'm going to do that same exact thing starting at B. Remember, it was up 4, 3 to the right. 1, 2, 3, 4. 1, 2, 3. And that would mean right there. And that is point C. So I'm going to connect this now. And that looks pretty good. And it's just a freehand drawing, of course, so it's not totally accurate. But that's the idea. And the coordinates of that point would be 10 and 6. 10, 6. So the coordinates of C, the point that was missing, would be 10, 6. Alright, so that's an example where you're working on a coordinate grid. Oftentimes we'll be talking about slope and of parallel lines and perpendicular lines. And that was an example of a quadrilateral, in other words, specifically a parallelogram. Let's take a look at a second example. Alright, here we have a second example. This one I start over here on a coordinate grid, and I have 2 points, point A and B. Coordinates of A are 3, 6, coordinates of B are 9, 3. And so over here on the right hand side it says AB, so this segment, is the leg of a right isosceles triangle. The right angle is at point A. Find point C to complete the triangle. So there's a couple of things that you have to understand in order to complete this. You have to understand what the word right means. You have to understand what isosceles means. So right means that there's a 90-degree angle right here. And then isosceles means that the length of this side will be the same as the side that connects A to C. That's the other leg. And this ties back again to slope. And so in order to do this, I'm going to count, let's see, how far do I go down from A? So 1, 2, 3, and then 1, 2, 3, 4, 5, 6. So this is a negative slope then of negative 3 over 6, negative half, that would be. Negative 3 over 6. Now, the slope of a perpendicular line, that's what that symbol is there, would be the negative reciprocal. So you take this slope right here, you flip it, and you change the sign. So the slope of the perpendicular would be 6 over 3. So let's try that. Let's go up 6. So let's see here. 1, 2, 3, 4, 5, 6, and over 3. 1, 2, 3. Now let's go ahead and connect that, and those are exactly perpendicular because the slopes are what we call the negative reciprocals of each other. And to complete this, then, I can go ahead and draw in the hypotenuse. And that's guaranteed to be a right angle because, like I mentioned, with the slopes. And so this is a great problem on a coordinate grid. It forces you to understand all of the geometry terms along with a slope of perpendicular lines. So those were two examples of showing or knowing what you know about the properties of triangles and quadrilaterals using a coordinate grid.